energy stored in terms of T and E vector. Okay, so the energy density is given to be WE, that is equal to half into summation of I is equal to 1 to N QI into VI joules. So this is energy density, and energy stored in terms of D and E, that is nothing but WE is equal to half into volume integral epsilon naught into uh, E square dV joules in terms of E, that you can convert into D by using the flux density relationship. Okay, so now we shall discuss so about the electric dipole, a very important concept. So before that, so we shall solve one more problem on the energy density. Okay, yes. So find the next problem. Find the energy stored in a system of in a system of in a system of four identical charges, four identical charges of 4 nanocoulomb placed at corners of a square of side 1 meter. Okay, this is what you have to find. So there are four identical charges of 4 nanocoulomb are placed at corners of a square of side 1 meter. So you have to find the energy stored. You have to find the energy stored. So that is what you have to find here. So let us have a square like this: Q1, Q2, Q3, and Q4, and they are at a distance of 1 meter apart. So you are required to find the energy stored in this system of charges. Okay, so Q1 is equal to Q2 is equal to Q3 is equal to Q4 is equal to 4 nanocoulomb. 4 nanocoulomb. Okay, so this is what you have to find. Okay, yes. So you can place the charges in the order of like this only. That is Q1, Q2, Q3, Q4 in this order only. Okay, so when Q1 is located, okay, when Q1 is located, W1 will be equal to 0, as there will be no work done. Okay, So W1 will be 0. When Q2 is located, when Q2 is located, so there will be some work done because the field is created by Q1. So W2 is equal to Q2 into V2 and Q2 into potential due to charge 1. Okay, it is nothing but Q2 into this Q1 by 4 pi epsilon naught and R21. Okay, so you have to solve this one. I'll just leave it to you. Okay, next you have to solve for W3, that is when Q3 is located, so that is W3 work done. So that is nothing but Q3 into V3. The potential will be due to the charge 1 and will be with respect to charge 2. So Q3 into V31, that is nothing but Q1 by 4 pi epsilon naught R31 plus Q3 into Q2 by 4 pi epsilon naught R32. So that is W3. Okay. Next, last one, when Q4 is located, so that is nothing but W4, Q4 into V4, that is nothing but Q4 into potential at 4 due to charge 1, potential at 4 due to charge 2, potential at 4 due to charge 3. So you will be solving for the V41, V42 like that. So that is nothing but Q4. So it is nothing but Q1 by 4 pi epsilon naught R41 plus Q2 by 4 pi epsilon naught R42 and Q3 by 4 pi epsilon naught R43. So we have to solve for this W4. So you're supposed to find the distances, right? So that is nothing but R12 you should know, and you should know R23, you should know R34, and you should know R41. These things you have to calculate. Okay, so if you solve for it, okay, so that is nothing but 1 meter. You get it as 1 meter, 1 meter, 1 meter, and 1 meter because distance between 2 points is 1 meter. Okay, but the distance between the 2 4 and 1 3 is different. The distance between the 2 4 and 1 3 is different because there is nothing but diagonals of the square. So that turns out to be uh, R31 and R24. They are nothing but length of the diagonals of the square. So that is nothing but square root of 2 and square root of 2. So it is nothing but hypotenuse. I can solve for it. That is root 2. Okay. Hello. Yes. Now you just have to solve for the values. So that is W1 W2, W3, and W4. W1 is equal to 0, W2, W3, and W4. So I just leave it to you. You can solve it. Okay. Yes, the total answer would turn out to be around 778.62 nanojoules. 778.62 nanojoules. Yes. If this is clear for you, please type 0 on the chat box. Now we shall come back to the concept again. It's nothing but electric dipole. So you might have studied dipole in your chemistry. Okay. So here you will study electric dipole, the field due to an electric dipole. So that we shall study now. So what is dipole? Uh, it is nothing but whenever there are 2 point charges of equal magnitude. So there are 2 point charges, okay, equal magnitude and opposite sign, opposite sign, and when there are when they are separated by a small distance, and they are separated by a small distance, it gives rise to an electric dipole. Okay? The field produced by such a dipole is nothing but field due to the electric dipole, which is very important concept in field of electromagnetics. So, for example, if you have a charge like this plus Q, and you have to have equal charge of Q with an opposite sign, and it has to be separated by a small distance d. Okay, you can find field at this point. The field will be from this charge and this charge. Okay, so therefore there exists some field at this point P. So as a result, you'll be having some field due to this charge arrangement. This arrangement is called electric dipole. Okay, so you'll be having some field due to this positive charge, and you'll be having some field due to this negative charge. Okay, let us derive some equation for electric field due to this arrangement. Okay, yes. So let me have a scenario like this. And this is z-axis, this is y-axis, and this is x-axis. Let me have a point A here, and let me have a point B here, and I'm having plus Q here and having minus Q here. Okay, let me have a point P here. So I'm interested in finding a field due to this set of charges, and that point P is a distance of R1 from A, and point P is a distance of R2 from minus Q, and let it be at a distance of r from the origin, and this r is making an angle theta with respect to the z-axis, and the distance between A and B is d. Okay, and the coordinates of the point P is assumed to be specified in spherical coordinates. Is assumed to be specified in the spherical coordinates. Okay, so now the A coordinates are uh, 0 comma 0 comma d by 2, and B coordinates are 0 comma 0 comma d by 2. Okay, minus d by 2. These are the coordinates of A as well as B. One second. Okay, so now the coordinates of A and B are obtained like this. Okay, so you can find E at the point P if you are able to find the potential at point P and then take gradient of the potential. So you can find the intensity at point P if you're able to find V at the point P. Okay, that is my um, comprehension at this point of time. Okay, yes. So let us find the potential at P due to charge 1, that is due to Q, and let us find potential at P due to charge minus Q, and add both of the things. You will be getting the total potential at a point P, and then you can take gradient of it. Then you'll be getting the electric field due to an electric dipole. Okay, so uh, let me have the at uh, potential at P due to charge plus Q plus Q. So that is V1 is equal to plus Q divided by 4 pi epsilon naught, and the distance between plus Q and P is R1. Directly you can write as R1, and potential due to minus Q at P, that is V2 minus 2 divided by 4 pi epsilon naught. The distance between Q and P and minus 2 is R2. So you will be getting it as R2. So total potential at point P is V. Therefore, if you simplify it, you'll be getting it as Q, okay, Q by 4 pi epsilon naught R2 minus R1 by R1 R2. So this is what you'll be getting. If you further simplify it, you will be getting like this. Okay. So if from this you can check out if R1 is equal to R2, then the potential is zero. The potential is zero. That means it is assumed to be an infinity point. Okay, it's a reference point. The voltage is zero, so it's assumed to be what? It's an infinity point. This might happen whenever R1 is equal to R2. Okay, yes. So this is nothing but the potential due to the electric dipole. From this, you can get the gradient of potential, and then you can get it the electric field due to the dipole. So now, what if the point is farther away? Okay, here the point is like this, very considerably at a nearest distance from A and B. What if the point is farther away from A, B, and O? How the dipole behaves? That's the next part. Okay, so that is nothing but when point is too far away. When the point is too far away from the system. So let me do like this. So this is A point and this is B point. Okay, and I will just drop the line like this from origin like this and from B like this. Okay, so the point is very far, somewhere else here. Okay, and this what I will do. They are assumed to be parallel lines because it is P is assumed to be very far away from the charges. Okay. Yes. For that case, what I will do, I will just drop a perpendicular to this point. Let it be AM, and this is nothing but theta. If this is theta, this also becomes theta, and this also becomes theta. They are nothing but the complementary angles. Okay. So R1, R2, this is R1 and this is R2 and this is R can be assumed to be parallel to each other. Okay. Yes. So now, what is that we have to find out here? We have to find out the V. So V is equal to Q by 4 pi epsilon naught R1 minus R2 by R1 R2. This is the expression when point P is very much closer to the dipole. When it is farther to the dipole, what is the expression for V? That is what we have to find out here. Okay. In that case, what is that we have to calculate now? Okay. So dimensions, we just concentrate on the dimensions. What is that AM? What is that BM? And what is that PM? And what is that AP? So all those things is very much essential now, so that we can derive the expression for electric field due to a dipole. Okay. Yes. So here the we have dropped perpendicular from A, that is A to this R2. So your PM, that is nothing but this equation. So BM, that is AM is perpendicular to PB. Sorry, it is AM, that is AM is perpendicular to PB. Okay. As a result, your BM is equal to AB cos theta. BM is equal to AB cos theta. Okay. And that is nothing but D cos theta. That is nothing but D cos theta because the distance between A to B is d, and this becomes your hypotenuse, and cos theta is equal to adjacent side by hypotenuse, that is nothing but d cos theta. Okay, and total length from P to B, so that is equal to PM plus BM, and also your PM is equal to AP because AM is perpendicular. Okay, so PM is equal to AP or PA, so you'll get PB as equal to AP plus PM. Okay, so PA or AP is R1. Okay, and this is nothing but BM, but PB is also equal to what, R2. So R2 is equal to R1 plus BM. Therefore, R2 minus R1 is equal to BM. Therefore, BM is equal to d cos theta. So from this expression, what you can write R2 minus R1 as d cos theta. Okay, and almost R1 is exactly approximately equal to R2. So therefore, so that you can take it to be equal to as R also. So you can get the expression like this. That is V is equal to Q by 4 pi epsilon naught R1 minus R2 by R1 R2. So it is Q by 4 pi epsilon naught R1 minus R2. We have solved it as d cos theta, and R1 R2 as take it as R square. So V is equal to Q by 4 pi epsilon naught d cos theta by R square. Okay. So now for to find E, you can take gradient of V, negative of the gradient of V. So gradient of V is nothing but minus of dou V by dou R AR cap plus 1 by R dou V by dou theta A theta cap plus 1 by R sin theta dou V by dou phi A phi cap. So in this expression, we don't have any phi term, so you can neglect this term, and then you can solve for E vector. So E vector is equal to uh, minus of dou V by dou R AR cap plus 1 by R dou V by dou theta A theta cap. So you have to differentiate V with respect to R. That means d by dou R with respect to what, Q by 4 pi epsilon naught d cos theta by R square. We have to differentiate this one, and with respect to theta ones. Okay, so Q by 4 pi epsilon naught d cos theta by R square. So if you differentiate this one, once with respect to R and once with respect to theta, so what is that you are going to get here? So it is nothing but minus 2 into Q into d cos theta by R cube, and minus Q into d into sine theta by 4 pi epsilon naught R square, and this also here get 4 pi epsilon naught. Okay, if you substitute back in the original expression, you will be solving for E vector, that is equal to Q into D divided by 4 pi epsilon naught R cube 2 cos theta AR cap plus sin theta A theta cap. So this is electric field at point P due to an electric dipole. Okay. Yes. Now we shall discuss about the dipole moment. Dipole moment. Okay. So what is a dipole moment? So the product of Q and D vector, that is equal to what? The dipole moment. It is given. It is denoted by P vector. It is denoted by vector. Okay. Yes. So let us derive some expression for dipole moment. So let my D vector in this case, it is along the Z axis. It is along the Z axis. So as a result, my D vector is equal to distance, that is magnitude D in the direction of Az cap. Okay. So your dr now. So now your D vector is equal to D into Az cap, and component of D along R direction, that is nothing but like this. Okay. D vector into AR cap, and nothing but Az cap into AR cap. Okay, this is nothing but the dot product of this one, dot product of this one. So it gives to what? D cos theta into the nothing but D cos theta. So this is dr. Okay. Therefore, D vector is equal to D cos theta into AR cap. Okay. So the dipole moment, as we have discussed, it is nothing but product of Q into D vector. Okay. So as a result, you will be getting it as like this. That is P vector into AR cap is nothing but Q into D vector into AR cap, nothing but Q into D into cos theta. So, but we know that V is equal to Q into D into cos theta divided by 4 pi epsilon naught R square. It is nothing but P vector into AR cap divided by 4 pi epsilon naught R square volts. So this is potential in terms of dipole moment. Okay. So you can also write electric field in terms of dipole moment, that is P by 4 pi epsilon naught R cube 2 cos theta AR cap plus sin theta A theta cap. Okay. So this is nothing but the expression for field intensity in terms of dipole moment. Okay. So you just have to recall these expressions in order to solve the problem related to this. Okay. So if you have got only one charge, that is called monopole. So if you got only one charge, that is, for example, it is plus Q, it is called as monopole, and the V is proportional to 1 by R, and E is proportional to 1 by R square. Okay, and if you have got dipole like this, plus Q and minus Q, V will be proportional to 1 by R square, and E is proportional to 1 by R to the power of Q. Okay, similarly it goes on increasing like this. You can have two dipoles. You can have two dipoles like this, plus Q and minus Q, and minus Q and plus Q. So this is pair of dipoles. This is called as a quadrupole. This is called as a quadrupole, symmetric arrangement of two dipoles. Okay, you can have symmetric arrangement of two quadrupoles. That's the repetition of this one. It is called as octopole. Okay, so it goes on. The potential goes on decreasing. As a result, field also goes on decreasing with respect to the dipole arrangement. Okay, so the potential is inversely proportional to the square of the distance from the dipole, and electric field is inversely proportional to the cube of the distance from the dipole. So this is what you have to concentrate. Okay, yes. So you have next class. Which class?
Max, sir.
So at 12:40. Yes. So I'll just stop at this point. So tomorrow we shall solve some problems um, on dipoles, and then we shall come back to the conductors, dielectrics, and capacitances, the new concept. Okay. So I'll just stop at this point. We can exit for the next class.
Thank you, sir.
Thank you, sir.